Given a polynomial function, determine the intercepts. Determine the y-intercept by setting x equal to 0 and finding the corresponding output value. And number 2, determine the x-intercepts by solving for the input values that yield an output value of 0. So for example number 8, we're determining the intercepts of a polynomial function. Given the polynomial function f of x is equal to x minus 2 times x plus 1 times x minus 4, written in factored form for your convenience, determine the y and x intercepts. Now in step number 1, the y-intercept occurs when the input is 0, so we're going to substitute 0 for x. So here's our function, and we're going to plug in 0 in for x. So we're going to find f of 0, which is going to equal 0 minus 2 times 0 plus 1 times 0 minus 4, which gives us negative 2 times 1 times negative 4, which gives us positive 8. So the y-intercept is 0, 8. Now the x-intercepts occur when we set the output equal to 0. So we're going to let f of x equal 0, and that's going to equal x minus 2 times x plus 1 times x minus 4. Now since this is already factored, we can use the zero product rule by setting each one of these equal to 0. So we're going to have x minus 2 equals 0, or x plus 1 equals 0, or x minus 4 is equal to 0. Solving for x for the first one, adding 2 to both sides, x is equal to 2. The second one, subtracting 1 to both sides, x is equal to negative 1. And the third one, adding 4 to both sides, gives us x is equal to 4. Now if we want to write them as ordered pairs, the x-intercepts are 2, 0, negative 1, 0, and 4, 0. Now we can see these intercepts on the graph of the function shown below. Here is your y-intercept at 0, 8, and then there's our 3 x-intercepts, negative 1, 0, 2, 0, and 4, 0.